Hi, welcome to today's webcast, Challenges and Benefits of Serverless Development. This is sponsored by Couchbase, but we have an awesome guest today from Forrester Research. A couple of housekeeping items. First of all, the chat function on your right, please feel free to add your questions throughout the presentation. But likely the Q&A will keep to the end. We have a lot of content, but we'll try to get to everybody's questions at the end towards the end of the presentation. Secondly, their slide deck for this presentation, as well as some other Couchbase resources, are available in the docs section. So with that, I will turn it over to Jeff Morris, Vice President of Product Marketing at Couchbase, to introduce our guest.
Thanks so much, Suzanne. Welcome, everybody. My name is Jeff Morris, and I'm really excited to go through and introduce our conversation today with Devin Dickerson. He's Principal Analyst at Forrester Research. I believe he's not in the. Are you online right now, Devin, on stage? That's what I thought. I didn't see him there. So I'm going to continue and start our conversation here. He'll be here in a second. We just have to jump him over. There he is. Hi, Devin. Great to see you.
Hey, thanks for having me.
So I think to start our conversation today, what I want to go through is first to talk about and kind of set the stage for what the context is from a Couchbase point of view, and then get your perspective on serverless development, serverless techniques, and some of the let's say the issues and things that folks are going to face. And then we'll have our conversation. I've got a list of questions that I have for you about as Couchbase looks to add this functionality sometime in the future. What are the things that we ought to be looking out for? So, whenever I talk to customers, and you and I, of course, were at reInvent recently, they're telling us right now that their core application development goals are to deliver a really killer user experience, be able to develop that experience or those applications really efficiently, and deploy them as effectively as possible. Now, I feel like I cover the deliver great experiences pretty well, and I'll walk through that in a second. But I can certainly see where organizations want to be accelerating their delivery cycles, right? Making things, simplifying their architectures, perhaps trying out new techniques like CI/CD, and then ultimately using their resources on the deploy efficiently side or effectively side, using their resources like their cloud infrastructure, like their database, like their application resources as efficiently as possible. I guess, what do you see right now? Is there still a lot of waste in cloud deployments?
Absolutely, particularly in the areas of cloud native patterns. I look at these patterns as something that's fundamentally about getting the most out of your cloud investment, taking advantage of the auto scaling and the pricing models, and those types of efficiencies. And when we fail to adapt to the development and design patterns that are built to take advantage and align ourselves to the way the cloud, to the way workloads scale in the cloud, I think we leave a lot on the table. Okay.
And certainly the when I talk to my customers, that the things that they hit me up for all the time is, one, help me fix performance issues of aging systems or of my first generation cloud systems. Two is help me be better at being agile, or significantly improve the flexibility of my application. And this is oftentimes like a driver for adopting a NoSQL system, to move to a flexible, schema optional or schema flexible kind of foundation, and then you can change and manipulate your data as you need without having to go and redesign or redeploy an entirety schema, like redeploy the entire application. Your application can be much more nimble. But the other things that we're hearing too is, produce mobile experiences that folks may not have had in the past, or yet their users are absolutely moving in that direction, especially given the last 3 years. And then finally is that drive down my overall operational costs and my cost of deployment or cost of development. So when we look at this, and this is kind of, play along with me here for a second, but I think exactly what you had just mentioned of being as efficient as you can with your resourcing, and ultimately coming up with ways to perhaps simplify your designs even will allow you to gain more benefit out of these new design, deployment, and delivery patterns that serverless and CI/CD kind of will offer us. One is, the overall simplistic view of an app is, you've got your infrastructure. From my perspective, it's usually data driven. So you've got a database running in the infrastructure along with the rest of your application. And then the application code that your team is writing, that are the core functional requirements. Now, the funny part to us is that oftentimes from the database perspective, it looks like this, right? It's a mess of microservices, all of which, or many of which, are calling one or more different database services to feed the database different pieces of functionality, whether that's support transactionality from relational systems, or support things like geographic search or text search from a search system, or maybe be flexible about your account profile with a JSON document database. But excuse me, but make sure that the application itself runs very quickly. So support session caching and such with something like Redis or Memcached. That kind of principle of pick the right database for the right set of functionality for your application is kind of the state of the art of application development, and I think is actually one of the genesis for the evolution of how databases themselves have evolved or are continuing to evolve, because of course this common design principle of using that perfect thing for each type of functionality creates a lot of complexity inside of your application. And from our perspective, it creates what we often characterize as data sprawl. Right? For every one of those data stores that you're carrying around, you've got to, if it's highly available, you need 2 or 3 copies of that data store, for each database. Well, that gets expensive on the storage side. It gets expensive on the infrastructure side, and of course, you have integration or synchronization or replication that needs to go on between these disparate systems, so that they're all kind of with each other. And all of which is really inefficient. But that accepted principle of polyglot persistence is, that it's okay for the developer to take on more complexity in order to provide really killer functionality to their users. And that principle has been going on for almost a decade now. But you'll see folks like our, I guess even this particular problem doesn't get any better when you look at cloud deployments, right? So if you look at this retail design that I pulled off the web, you've got 1, 2, 3, 4, 5 different database technologies driving this retail application, including DynamoDB. You've got RDS for transactions. You've got Elasticache again for that session caching. That kind of design just seems too resource intensive and perhaps wasteful, especially when you can use something like Couchbase Capella, which supports all of those capabilities all in one. So that fundamental principle of Couchbase is of being fast, right? We support memory first processing, just like a Redis does, or just like many other systems. But its foundation is a JSON document database with multi-model access points or access engines to that data store. So you have that flexibility to modify your schema or modify your data structures from the application itself. So if you need to add something, you just roll out, you just put it in the application and the database will take care of it. But then it also has all the fundamental familiar things that you expect out of a database, like transactionality, like that schema if you need it, SQL as your query language. We call it SQL Plus because it's SQL for JSON. as well as things like cost-based optimization or support for your favorite software development kit. And then ultimately, because it's fast, it is much more affordable when you're deploying it in the cloud. Now, there's a couple of really interesting things, and this is kind of when you didn't have serverless, what would you do to optimize your resourcing? And this was an early a Couchbase capability. We call it multidimensional scaling. And what it meant was each one of the engines that Couchbase has, an engine for query, an engine for key value access, an engine for search, one for streaming and eventing, one for parallel processing analytics, and the like. So these services, you can specify how much cluster resource you apply to each service. So in this case, the data service is on 3 nodes of the cluster, while the other services are running on 2. So you can try to performance tune your application or isolate the workloads of each service to optimally use your infrastructure. So I kind of, before a full serverless design, this is, taking advantage of typical cluster design pretty effectively. As you can see, even as we deploy it in the cloud, you operate everything on a control plane. You have your data sources backed up. If you need it to be distributed globally, we have replication, those kind of capabilities. All of which, of course, is managed, by Couchbase in the cloud. The product we for this, we call it Couchbase Capella. It's a fully managed database as a service. It supports HIPAA and is SOC 2 Type 2 compliant, so it's enterprise level secure. Still gives you that flexibility, super high availability, etc. All available from Couchbase, as a service. And some of the interesting things is, we took this GitHub-like operation most recently in our newest release, and have introduced some clever things like direct access to the query workbench from within the environment. You would kind of expect that, but we also have tutorials built in. So if you don't know SQL++, which most people would because they know SQL, it's really easy to test something out or to try out a concept directly from the interface before implementing it in the database. And hopefully, as we kind of walk through this, you'll notice it looks and feels a little bit like GitHub, because that's what we were going for when we were building this, is support a very developer forward kind of design while we're building it. Now, because of that multi-model support that I just talked about a second ago, the interesting thing is my customers told me that when I surveyed them a while back, almost 60% of them said, I was able to save more than 50% on my infrastructure when I moved over to Couchbase itself. So this is kind of the performance boost that you get out of Couchbase versus other products is really beneficial to organizations. And this is all without ourselves being what we would officially be described as being serverless. So ultimately here, when as I look at it, right, from our perspective right now, I can still deliver fast release cycles or faster. I can support reduced data sprawl by eliminating a redundant data stores. We can scale globally. I can support mobile deployments, which many systems can't. I even have a embeddable database that supports peer-to-peer syncing. Like I could sync tablet to my phone and then have my phone sync to the cloud. That kind of capability is really clever inside of Couchbase, but ultimately help drive down operational costs. And this is all without having a fully serverless offering. So my intent here in inviting Devin to have this conversation with me is I want to find out about his perspective on what's going to happen to ourselves and to to the cloud market as service becomes more and more popular. So Devin, let's walk through your material first, and then I've got a bunch of questions for you that I want to go through as we continue. I'm happy to drive slides if you like, but if you want.
Yeah. No, that works. You can drive slides, and I'll just tell you when I'm ready to move on.
Yeah.
So first, just a brief look at the serverless market. Won't dive in too deep there, but I'll just say that we see this market as growing. growing and rapidly maturing. In my research, I've spoken to many different serverless developers, enterprise leaders, and many of the major vendors in this space. And one thing that I am definitely convinced of is that serverless as a term can be a bit of a misnomer. So much of the marketing and stated promise of serverless is centered around this idea of lower infrastructure overhead, automated scale, and rapid development and deployment. And for the most part, this is absolutely the case. But one thing that I think is important to keep in mind is that when we say there are no servers and no infrastructure and no concerns outside of our business logic, that statement is really limited to the capability of our serverless functions themselves, unless you seek out dependencies and additional components that are serverless, which I think is what Jeff was alluding to with serverless offerings on the data side.
Mm-hmm.
If we look at what we at Forrester consider the serverless environment, and we look at this graphic, we can see that we have multiple layers here. So let's cover some of the highlights. At the center, we have the core serverless environment. And some key points. Serverless functions are designed as ephemeral instances. This is really underpinned by the idea of having discrete single responsibility functions developed within a fast platform. And up front, we know that these are designed to run, do their work, and then power down. It's really maxed out ephemerality. So for this reason, we consider it a best practice to design functions as small services that focus on doing one repeatable task extremely well.
Mm-hmm.
And as the number of functions an enterprise is managing begins to increase, this single responsibility approach becomes a lot more critical because things can get out of hand in a hurry. Another point, serverless functions typically run when they are invoked by events. They're often event-driven. So service communications and methodologies like event-driven design provide the glue that enables the integrations of multiple functions to work together and to also interoperate with other cloud-native applications. They also serve as a way of connecting compute logic to data, because in the cloud, it's often a best practice to decouple your compute from your data layer. But when this gets out of hand, it can lead to that sort of database sprawl that Jeff alluded to earlier. And so much like microservice design, events for functions exist in domains, and understanding domain-specific events and the business domains around them is a good starting point when you start to think about your serverless design. Another point here, serverless functions are inherently stateless. And so that separation of compute logic from the shared global state of an overarching cohesive application is actually what makes it so much easier to scale. And it's part of that scalability model with serverless. It makes it easier to spin up new compute instances that can then scale back down to zero when work is completed. But this leaves state in a separate managed storage or data management service. And while for some systems, state is managed in a more traditional database, but many I'm finding many more are looking to take advantage of some of the emerging capabilities in the serverless database market, as Jeff was alluding to. Last aspect of this sort of core serverless approach that I'd like to cover is just the auto scaling. And this is where that first point about breaking functions into small independent tasks is really crucial, with auto scaling horizontal scaling in particular being the inherent feature of the serverless platforms. Developers can really gain the maximum benefit of this by analyzing their workloads and breaking them down into the smallest, most independent tasks possible. And this becomes really important when people are breaking up monoliths. This can be a very important task to undertake to understand how to break things down into the smallest units imaginable. And then, so as we move out from the core of the graphic, we start to get into some of the things that speak to the shared responsibility model for serverless. And what that really means is that while serverless functions and approaches minimize the things that we as developers have to manage outside of our code, I've spoken to a lot of developers and discussed how their systems actually function in production. And I found that teams leveraging serverless still end up using an expanded environment of technologies and products to deliver their capabilities. It's not just all about the functions as a service platforms. Yeah, and so we've already covered state, data capabilities, but we also have serverless functions communicating to container-based microservices as well, not just serverless functions. And that, once again, that's that concept of serverless functions might be part of a larger system. And those things, you have to consider things like developer tools, event management, DevOps tool chains, and external integrations. And all of these things potentially sit within our system boundary, even when we leverage serverless. Okay, next slide. So the data from our developer and cloud leader surveys shows that serverless approaches continue to gain traction. This lines up with some larger trends that we're seeing in the cloud native development space as well. And I think part of what's driving this is this concept within DevOps and shift left. They've really delivered on the promise of bridging the gap between developers, platform engineers, and ultimately the customer. But the you build it, you run it movement has kind of shifted some complex infrastructure and operations concerns over to the developer, who is now responsible. Yes, and I hear a lot about this. And there's a lot of different folks out there trying to tackle this problem. But in shifting it over to the developer, who's now responsible for the total lifecycle of their application in some capacity. And developer retention is a huge problem for a lot of enterprises. And so improving the developer experience and productivity is really becoming a key priority for a lot of enterprises. And I look at serverless as one viable way to remove some of the infrastructure and operations related friction impeding developers from focusing on their code. So for those who might be uninitiated, let's take a look at how it does that. Next slide. So for those new to serverless, serverless presents infrastructure as a managed service. Keying in on this, the central idea is that most functions are created through interacting with a functions as a service platform. And normally, if in a traditional, even in a cloud native scenario, developers would still have some say and some responsibility in terms of how that application is deployed. They might still be wrangling with YAML files to get their containers to run on Kubernetes. There might be configuration to consider when it comes to networking, resources, storage. When you go with the serverless approach, all of that is abstracted away, and the functions as a service provider handles all of that in the dark green for you. And really, it allows the developer to focus strictly on their business logic, their design patterns, how the application is presented to the user, and the APIs, the ways that the service is invoked through events. And so we don't have to worry about instantiating infrastructure, deploying our application instances, or even how our application is going to scale. Next slide. So we talked about a lot of the good. I'd like to go over some of these challenges that I believe, according to my research, limit serverless adoption. And when I say limit serverless adoption, serverless is being used out there by a lot of development teams. But when I talk about limitations, I'm talking about crossing over into more mainstream use cases, mainstream web use cases. So when we talk, if you're familiar with serverless, you've undoubtedly heard about cold starts and how cold starts in certain real-time use cases can make applications seem less responsive. So dynamic provisioning is one of the most heralded advantages of serverless computing, just as we just discussed. But whenever a serverless application needs to scale up, the runtime environment automatically spins up a spare worker node to handle the load. Cold starts are nothing more than a natural byproduct of this provisioning model, with spin-up times varying by cloud provider offerings, package size, and a big driver is function dependencies. Larger packages with more robust dependencies tend to exacerbate cold start issues. So monitoring. The ephemeral nature of serverless functions, I have noticed myself and talked to a lot of developers, and it really makes observability a unique challenge. The native logging and monitoring offerings from the cloud providers, while they have matured over the years, still leave visibility gaps. But there is an emerging category of observability tools, third-party and also within the cloud providers that are tailored explicitly to serverless functions and removing some of that headache. Testing kind of ties into the observability problem, and it comes down to the distributed ephemeral nature of serverless functions and how they create challenges for developers and software test professionals. Many developers still prefer to code locally as well, and this carries additional considerations when using many of the functions as a service platforms on offer. That means that in order to test these things properly or to create automated tests, you have to figure out a way to mock up the cloud services to make them available for local testing. And serverless also carries additional integration and configuration risks as applications grow to include more functions and more dependencies. And finally, state. State is definitely a huge complication because serverless components are stateless by design. And as serverless enterprise adoption has increased, serverless developers have started to move into more of those mainstream use cases, and those mainstream use cases often are stateful use cases. And so while this has opened up serverless to more of that mainstream web use case, it also has led to developers sometimes facing challenges navigating this wide world of various vendor products that help manage state. And Jeff mentioned earlier the sort of sprawl that can occur if different teams are picking different data solutions to manage this state problem. Okay, next slide. So my research uncovered these 4 best practices to maximize the benefits of using serverless. So the first one is to pair your functions as a service platforms with event-driven microservices. And we touched on this a little bit, but the key point I want to highlight here is that FaaS platforms are really only the starting point for serverless applications and workloads. Excuse me. To build more complex, what I would call real-world applications that solve real business problems, we need to start thinking about how our functions work together to deliver a cohesive capability. And that requires applying similar patterns to what we would see with event-driven microservices. In order to implement this, serverless developers need to look at designing a taxonomy of events and domains, understanding the business domains that our functions serve, and those domain-specific events that we derive from that are a great starting point for microservice design and are therefore a great starting point for serverless design, serverless function design. And the event approach allows developers to more easily add new services that listen for events while still promoting loose coupling, especially relative to the request and response model, which really ties services together and it's under a specific sort of contract. Yes, and we also want to use event queues to drive auto-scaling performance. We don't want our individual functions to be overloaded by events. And we want our microservices to be able to respond to the same event. So different microservices being able to respond to the same event is really key. An example of this, to sort of simplify the concept, is let's say a user updates content in an e-commerce order. We might have an event fire off that could be used to update the inventory while there's another service listening to trigger a notification service to send a confirmation email to the customer. And kind of tied into that, I also recommend having multiple versions of the same service, be able to respond to the same event. And with this, just think about canaries, blue-green deployments, the ability to evaluate new service versions in production. Okay, so next best practice, thinking about designing functions with auto scaling in mind. And this applies across the board to cloud native, but is particularly important to serverless. We want to design for parallel execution, and we want to think about asynchronous design approaches. Execution time is the biggest cost driver in the serverless approach. So serverless developers really benefit by minimizing the amount of time functions are spun up, but spent waiting to do work. We want them to spin up, do their work, and go away. And another aspect of asynchronous design is thinking about how we chain functions together. And part of how we do this is with workflow orchestration tools. And I have a slide in a little bit that'll just explain a little bit about what the workflow orchestration aspect about this is. And the last thing I'll cover is, and once again, some of these apply to all cloud native, but serverless is sort of cloud native on steroids. And so embrace change with fault tolerant services. In distributed systems, and I consider most cloud native applications to be distributed systems by nature, failure is inevitable. I've worked with a lot of distributed systems in my career, particularly when I was working on Navy projects where our software was deployed across different ships in the fleet, or where I was working with Army or DoD medical programs, and our software was distributed to all of the battalion aid stations in the theater zones. And so I'm no stranger to distributed systems, and I know that when you're dealing with these things, you have to understand that infrastructure and networking failure is basically an inevitability. And while serverless developers don't need to manage infrastructure and networking for their functions, the applications themselves still have dependencies and interfaces, especially as you bring in those stateful use cases. So it's really important to understand that up front. And so despite that separation of development and infrastructure concerns, our serverless applications can still fail due to those dependencies. Also another thing to keep in mind is that the way serverless functions scale out might not be compatible with some of the dependencies we introduce into the system. The dependencies we introduce have to be cloud native in nature as well if they are going to accommodate the horizontal scaling of serverless functions and don't run into some of those service limits that horizontal scaling can have us bump into. Okay, next slide. So I just wanted to highlight a few of the use cases that came up in my interviews with organizations that are leveraging serverless technology. We found these 5 use cases to be the most commonly cited. So going through some of these, when we talk about CI/CD automation in this context, what we're really talking about is actually serverless functions underpinning the technology approach to implementing CI and CD. So a code commit emits an event that maybe triggers an application to build, or that perhaps triggers an automated test suite to kick off. Our serverless functions can actually be the underpinning technology for CI and CD. Video and image processing, a general purpose web use case, a user or customer uploads a photo or a video, and this triggers an event that will kick off, maybe the image to be resized or a video to be compressed. Number 3 is actually one of my favorite ones, and this kind of comes back to my own life, my past life as a practitioner. But back in the 2000s, there was a big movement on the military application side to go with commercial software wherever possible. And these days, COTS software, commercial software, is often a SaaS application that's hosted in the cloud. And oftentimes, when an organization brings in a SaaS solution for one of their business needs, it's usually something like an 80 to 90% solution. It's not custom software built for your specific business. It covers about 80 to 90% of your requirements. And the idea is you kind of have to either bridge the gap yourself or just live with it. And if you ever have to convince a SaaS provider to customize an application for you, or to provide a custom baseline for you, it's extraordinarily expensive and generally just a really bad idea. I look at serverless, and I've talked to some people who are actually doing this, which I think is really cool. They use serverless functions as a way to create some customizations at the edges to sort of bridge the gap between the 80% solution and the 100% solution that's completely customized for your business. And so, yeah, those are some of the highlights on use cases for serverless. As I said earlier, seeing more and more general purpose use cases as developers start to bring state machines and workflow orchestration into the equation. Next slide. So I won't go through this whole thing, but I wanted to include this just to illustrate the point that oftentimes when we talk about serverless functions, people are thinking about the individual function and how they scale out and how they spin up and go away when their work is done. But in order to achieve more robust use cases and to build true full-blown applications in production, we have to also think about how our functions are going to orchestrate and work together. And serverless workflows are a way of tying functions together with events, and this allows, even in a situation where state management remains a challenge, you still have a way of creating a step-by-step workflow where the outcome is greater than the individual parts. And so we see this with serverless workflow orchestration tools. And with that, that's all my slides, Jeff.
Yeah, so I think what you've raised a bunch of really interesting issues that I want to go back through and and cover. So I'm going to put this slide up just so that we can kind of maintain a little context for people, or something better to look at than ourselves. But the first thing I thought of was, as we deal with the stateful and statefulness of data and statelessness of the application itself. From the data side, right? One of the and this has always been one of our concerns while we're serving data to serverless operations or microservices, is the fact that Couchbase itself is doing everything in memory first, allows us to deliver data back to the service really, really rapidly. But then there's some other interesting interesting capabilities, like the fact that wherever a collection of documents is stored, and a collection is an organizational term inside of Couchbase and many document databases, where a collection lives, right, is we process all the data at the collection level. So if data itself is organized appropriately for each microservice, as I just need this collection of documents for this particular service, then that in-memory processing can happen really quickly, as well as the dealing with either updating or adding or simply reading the documents themselves. The database can be matched to be really responsive to each service. Yep. The interesting thing here is that when we design our operation, is one of the things you mentioned earlier, is you need a hot service and a cold one, or a standby, ready to if the original fails. Well, the database itself has to we kind of have to have a pilot light on with the database also, waiting for whatever service event is going to happen to trigger a database activity. So having the database hibernate with let's say with a candle on would be kind of the way in which we would want to build out the stateful side of this, or the database side of this. That's kind of in the area of database on the server side, serving serverless operations or serverless functions rapidly. But there's two other things that I thought we were talking about here. One is the fact that we actually have an embeddable mobile database that we could, that goes offline, right? Because much of this serverless capability requires the cloud, requires the internet, and yet, as you mentioned, we know that the networks are not reliable. Therefore, your internet's going to fail, and you still probably need your phone to work, or you need the screen on your car to work, or you need whatever that application activity is happening. So having an embeddable device that can maintain the operation, maintain the interactivity at that at the user interface level is really important.
Yeah, absolutely. That's kind of near and dear to my heart, because for a long time, my principal focus as a practitioner was on disconnected environments. Mm-hmm. And as the cloud became more ubiquitous, and we tried to start to use cloud native technologies ourselves, we always had the challenge of, how do we leverage the advancements that are happening in the commercial world with the cloud, with the fact that we have disconnected or intermittent connectivity environments. And that ability to maintain some system capability when connectivity is lost is critical for a lot of different requirements that you see out there.
Yeah, we have customers that very similar to what you're describing that are building pop-up mobile clinics just with a bunch of laptops, and they have a local LAN that syncs amongst the laptops, but and then so they can pop up wherever. The medical the doctors and the medical personnel, the caregivers can operate wherever they are, and then resync everything back when they get a clean or a live internet connection. But that holds true when we've got another customer who has automated the pre-flight checklist of for their airline, and they're syncing data between the pilots, the flight crew, the maintenance personnel on the ground, and the boarding staff at the gate. And we all know how terrible your internet signal is at the gate of an airport, right?
Absolutely.
Yeah. So
it turns out those disconnected and limited bandwidth use cases were not limited to the military application. I didn't know that for years. I didn't know that. I thought I was the only one suffering.
Yeah. Well, and our other favorite one is is the cruise line example, right? Cruise ships are basically floating cities. And and so our customer Carnival has built their medallion service. Their medallion system is the medallion that you wear as your room key, right? So you never really lose it. It's on your neck or on your wrist, but it's also your payment device, and it's also tells the crew where any particular people happen to be. And so their design, of course, is to deliver this great user experience to their passengers, but it also helps keep everybody safe. It also helps improve that level of service. Like, okay, so I've just lost all my chips in the at the blackjack table, but I ordered I ordered a Mai Tai, so I pack up. I'm kind of upset. I go to the pool. I'd really like but I'm still feeling bad about having lost a lot of money. And then my Mai Tai shows up, right? Because they know where I am. Or they remember what my kids like to eat at breakfast. They got to have the French toast and bananas, and otherwise they get really upset. So they're able to remember and customize my experience exactly for myself. Now,
No, I was just going to say that I think that you just touched on a really fertile area where I think serverless is going to become a lot more ubiquitous, which is at the edge. The serverless model is perfectly suited for edge computing.
Yes, that on-off kind of instantiation of serverless capabilities. I absolutely agree with you. And I think the way that we're even thinking in terms of, all right, so the Starlink network is hovering above the world, but it too creates has a lot of latency built into it. And yet the applications that you want to be syncing back and forth to the earth, still need to be available all the time. So yeah, all of that type of design we think is going to be continue to be really, really popular. Certainly, popular within the Capella space. But there's other interesting things that we can, that you've triggered for me, like when you're dealing with with data that let's say is bound to the earth, but there's regulations. Right, we've got GDPR, which dictates where data has to reside when it's stored somewhere, even if it's bouncing around while it's getting processed on an airplane, let's say. But it needs to land where its owner resides, and so being able to either you have to build your services to accommodate that, or pick a database that allows for filtering and replication to different site locations, different regions in your cloud, and making sure that data only resides in that particular owner's location. The database can kind of help take care of that. And yet at the same time, in Couchbase's case, we always tell the application where its data lives. And we would tell your functions, if they're making a call to us, the function would know, oh, well, this is data that resides in the Reston, Virginia data center. So always go there to look for it, right? Or even if if there has to be a network traversal to it, you can always locate your data. But then that also brings in the networks are slow problem, which I would end up, re-arguing. Well, that's why you put a mobile database or an edge service there to queue it up and make sure that it's close to where that user is. But there's this really interesting, get data to where it's supposed to be and present it to where it's going to be consumed as efficiently as possible. That I think serverless has got serverless designs will need to accommodate.
Yeah, and the old single large relational database that with a data access logic tier that used to be common in the traditional applications just doesn't work as well in serverless environments.
Mm-hmm.
And part of that is because we want to promote loose coupling,
Right.
because it makes the manner in which serverless applications scale a little bit safer, and it also we want to keep the resource demands down. We want to make sure that these things can run really quickly. Attaching your serverless functions to a behemoth database could really have you running into the service limits from the functions as a service provider rather quickly in terms of runtime.
Yeah, oh, yeah. And so the other thing, so I really like your thoughts on, where I kind of laid out the argument of the common practice, even as folks are building microservices, is to use multiple databases in their in serving their application. What's going to happen to that?
Sorry, I broke up a little bit.
Oh, sorry. So the polyglot persistent style of design, where that advocates offering the functionality to your application regardless of in the best way. So you use a relational database to support transactions, for example, but you might use a document data store to house the account profile of that user. So given those two systems, is that going to be a continued perpetuated kind of design, or what's your thought on the convergence of different database access methods to support these on-off again kinds of serverless designs?
Yeah, so I think that for people that were really early adopters or have been very sophisticated in their adoption of serverless, I think that those folks are going to go straight to the serverless database models and look to products that consolidate a lot of those features, so that you only have to worry about maybe having one provider, or at least minimizing the amount of complexity in your environment. And one of the reasons I say that, when I was interviewing serverless developers for my research stream over the summer, I found something really perplexing, and this really threw me for a loop. That people that develop serverless functions are still having to build out hundreds of lines of infrastructure as code to stand up their systems. Wow. And the reason for that is because of all the different dependencies that they're bringing in to make it an actual production-ready cohesive application. And so the more different technologies and dependencies you have to bring in, the more you kind of erode away the benefits of serverless in terms of letting developers dive in and focus just on their business logic.
Sure. Because you had already described that one of the issues that they're going to, even while they're doing the decoupling of services, and you want everything to be a discrete function, the amount of weaving of all of those events and the amount of weaving and making sure that you understand your traversals of functional design, that's where the complexity lies now, right? And so having the complexity of the fabric of your services, of your functions, you want to focus your complexity there rather than have complexity in and out of the infrastructure.
Exactly. The functions as a service provider is taking care of the application server and the container platform. Mm-hmm. But you're still responsible for a lot of elements of an application as you try to bring in more stateful use cases, especially. Yep.
Yeah. So I got another interesting question for you. Is what's going to happen in the area of where most of these functions as a service platforms are cloud specific. What's yet at the same time, the containerization model is steering people to be multi-cloud and and support portability across clouds. How do you resolve those two things?
Yeah, it's very interesting because from a certain point of view, the container model could be almost thought of as an alternative to the serverless function approach.
Mm-hmm.
But my viewpoint is that going forward, we're going to see more and more convergence towards those, and that vendors will be rewarded who create a unified experience for people developing applications that might need to deploy in a more standard cloud native way, like on containers and with Kubernetes. Or in some workloads might be a better fit for serverless. And I think that there's going to be considerable demand for products that unify the developer experience. Whether you're developing to deploy your own containers on Kubernetes or using a managed service for Kubernetes or using a functions as a service platform, I think having that unified experience is going to be really important for developers. And the reason I say that is because I think that there's no one size fits all for the entire application stack. I think to build great cloud native applications, you're going to have to use all of these tools that are available, all of these approaches. And so having a unified developer experience so that you can choose the best approach for your individual workloads, I think is going to be really powerful.
Yeah, I think we agree with you too. Although, but there's really funny, and your trades are going to be that portability versus portability. I guess I would characterize as portability versus performance. Depending on what you're trying to construct.
Yeah.
Love the universal developer experience across the board. Yeah, we definitely adhere to that. But one of the secrets that we found in evolving our own design was that when you're heavily committed to a Kubernetes-based environment, right, that absorbs resources from your infrastructure. And so, as soon as we started looking at what are the critical pieces that we need to keep and what are the things that we can accomplish through some other means, we made the database like 40% faster when we started pulling pieces out, the portability capabilities out, so that we could just focus on making a really killer price performance system, because that was again one of the top driver for why customers were picking Couchbase itself was the raw performance of the database. Is can you help me either shore up my existing system, or I've just got a lot of users, right? We've got customers like FICO that are supporting 3 billion credit card accounts, right? Searching every one of them for fraud against every transaction. That's got to be fast. And so,
right.
Designing for that and accommodating a customer's both performance requirements, those portability requirements, as well as that unified developer experience, they all come into play here.
Yeah, I definitely agree. I think that was an interesting example that you brought up, highlighting the trade-off between portability and performance. And that's something that, the amount of complexity that we take on as an enterprise becomes sort of a strategic decision. And as you bring in multiple providers, you introduce possibly more complexity. And then if you take on managed services that try to be everything to everyone, you might lose some efficiencies.
Yeah.
So there's definitely trade-offs. And I kind of look at the amount of complexity that we take on versus the streamlined management where you might lose some efficiency. It's sort of a strategic decision for your enterprise.
Yeah, no doubt. So I guess as we look to close out our particular part of the section and take some of the viewer questions. Let's have you got any advice for Couchbase as we continue to evolve our platform?
I think that the concept that you brought up earlier is a critical one, and it's this idea of sprawl with the different tools that you bring into your environment. I keep going back to that example about how much infrastructure as code serverless developers still end up writing when they bring in dependencies. And so if you've got 8 different data solutions that are each micro tuned to a specific workload, maybe just for a 3 to 4% gain, that might not be worth it. And so I think companies that position themselves to help reduce that complexity are really kind of super driving the benefits of serverless. We don't want to erode the benefits of serverless by forcing a ton of complexity outside of the functions themselves.
Yeah, so that you can indeed focus on on the quality of the functions. Right? It is to me. Yep. That simplification exercise is something that is quite critical, because the more complexity you eliminate, right, the higher quality application you end up building, right? Because it isn't bound by that, by the mess underneath. So yeah, I completely agree with that, and look forward to how this all evolves. I got a couple of questions here. I got one is, can you kind of reiterate how developers improve overall supportability of their serverless activities or their functions as a service? Like, kind of talk about what it's when you're building things. What do you do to make it more supportable? Once it's deployed.
Yeah, sure. So I think that supportability in serverless, I often think about looking upfront to spot problems with, and to find issues with how the application is going to scale. I'll also, just in case you're talking more about supportability from a different angle, I'll also throw out the shared responsibility model in terms of how you leverage cloud services is super critical. Just because functions as a service platforms immediately give you a blinking cursor that can have you from blinking cursor to hello world in 30 seconds doesn't mean that we deploy applications into production bypassing our organization's governance. We need to figure out ways to take advantage of the speed of development inherent to serverless, while also making sure that we're still going through the automated testing in our CI and CD pipeline, and that we're still taking advantage of those things that really kind of anchor the supportability of our applications as a whole. But thinking of supportability in terms of making sure the application remains well behaved going into the future, I would recommend augmenting your use of a functions as a service platform with better logging and monitoring tools.
Yeah.
This is a major shortfall. Maybe not a shortfall, but this is a major challenge, I'll say. In terms of making sure that you have full visibility. These serverless functions are firing off events into the ether, and we don't always, as an individual developer or a development team, we might not always even know who's listening. And so, and the traditional logging tools are often not well suited to handle a serverless system that can scale nearly instantly to hundreds or thousands of instances and then resolve back to zero in just a minute or two. And so I would look to enhance system observability as a means to anchor the supportability.
Got it. That's it. I like that insight a lot. I guess our final question here is for there's still a lot of organizations that are moving to the cloud, and I think even the research you showed said that about a third of your respondents are doing serverless development. Another third wants to, which implies that there's a third that hasn't thought about it yet. When does sort of the mass movement start to happen, or with the adoption of serverless? Or do you think it's underway?
Yeah, so I think that there's two things at play that factor into this. One is technology that enables serverless functions to be more applicable to general purpose web development use cases. And I think some of these state machines and these approaches to state management, while not introducing so much complexity that you almost eliminate the point of serverless, I think as that evolves and matures, I think that helps. And then for two, the edge. I think the future for serverless is at the edge. So the serverless model is perfectly suited to deliver capabilities in retail, manufacturing, and even in some of those disconnected ops use cases that we talk about, with the cruise ships and the forward-leaning sites that maybe aren't completely disconnected, but that have intermittent comms. I think that the lightweight nature and the horizontal scaling of serverless is perfectly suited to those environments. And I think we could see serverless. Serverless is arguably mainstream at the edge, and serverless is more than a viable alternative to Kubernetes container-based deployments at the edge, in my opinion. Yep.
Thanks so much, Devin. I think that's all our time. This has been really, really awesome to have you on this event. I appreciate it. Thanks, everybody.
Thank you. Take care, everybody. Have a great day.
Thank you.